It's going to be A, most of you have got it. It's going to be relative formula mass. So let's look at our notes. Let's add to our notes. So RFM, which we also call MR. How do you find out the MR of a compound? How can you do that? So for that, you need a periodic table. So down here, we've got periodic table. And what you do is you add up all, and we can get started. Come back, guys. So, yep, welcome guys, those of you who are just joining now. So quick question, what does RFM stand for? I doubt they'll ask you this in an actual exam. Just to get started, what does RFM stand for? There's only one answer. It's not going to be reactive force measure. I don't even think that's a thing. Hey guys, welcome back for those of you who came yesterday. So we'll just wait a bit for a few more people to join before we carry on. While we do that, just try and think about what the answer to this question is. So this live's all about moles, calculations, quantitative chemistry. Start off real easy. What does RFM stand for? Another word for RFM, we use MR as well. So once you've clicked on it, just give the screen a few taps and we'll wait for a few more people. So yeah, it's going to be same as yesterday. We're going to look at these multiple choice questions and we're going to look at some exam questions as well. At the same time, we're going to look at some notes on this. We're going to write some notes on quantitative chemistry. If you weren't here yesterday, I said it'll be useful for you guys to have a periodic table in front of you and a calculator. We're going to do quite a lot of calculations. So if you got some time now, just go and grab a calculator real quick. And we can get started. Come back, guys. So, yep, welcome guys, those of you who are just joining now. So quick question, what does RFM stand for? I doubt they'll ask you this in an actual exam. Just to get started, what does RFM stand for? There's only one answer. It's not going to be reactive force measure. I don't even think that's a thing. Resonant frequency modulus, I don't even know what that is. It's going to be A, most of you have got it. It's going to be relative formula mass. So let's look at our notes. Let's add to our notes. So RFM, which we also call MR. How do you find out the MR of a compound? How can you do that? So for that, you need a periodic table. So down here, we've got periodic table. And what you do is you add up all the relative atomic masses of the elements, or the relative atomic masses, the elements in the compound. So what do I mean by that? Let's pick a random element. Let's pick magnesium. So magnesium is 2412. Let's say we're looking at magnesium oxide. So magnesium oxide is MgO. So if we want to work out the MR or RFM of magnesium oxide, we'll look for magnesium. And then we'll look for oxygen. So oxygen is 16.8 and you'll add them together. So you always pick the bigger number of the two. So you got 24, you got 16. And because it's magnesium oxide, there's one magnesium and one oxygen, you just do 24 plus 16 and that'll give you 40. So that's the RFM of magnesium oxide. I hope that makes sense. So what we're going to do now is we're going to try some questions on working out the MRs of some compounds. So real quick, what is the RFM of H2O? Why don't you guys quickly work that out, comment the answer, tap on the screen a few times, and I'll reveal the answer. This live will be on YouTube, yep. So once I've done this, I'll upload it to YouTube. So we've got a mixture of answers. We've got B and A so far. No one's picked C. No one's picked D, rightly so. So remember what you need to do. You need to look for hydrogen in the periodic table. You need to look at oxygen in the periodic table. So what you have here is 2 hydrogens and 1 oxygen. So each hydrogen, if you look in the periodic table, hydrogen is a 1, oxygen is a 16. We looked at this earlier. Hydrogen is here. Oxygen we looked at already over here. So 16 for oxygen, hydrogen is 1. So you just add them all together. There's 2 hydrogens here, 1 oxygen. So you just do 1 plus 1 plus 16, which is 18. Answer is B, 18. Well done. Okay, next question. What is the RFM of ammonia? So these are going to get harder and harder as we go. On Google, it's saying 8 for water. That's wrong. Maybe it's for something else. What's the RFM of ammonia? So let's try and work it out the same. So look for what nitrogen is, look what hydrogen is, and add them together. Yeah, if you got a question, just yeah, you can message me. That's fine. So let me know, guys. So pick the right letter, tap on the screen a few times, and we can move on to the next one. So we're picking B. Yep, good. It's going to be B. Nitrogen is 14, hydrogen is 1. There's 3 hydrogens, 1 plus 1 plus 1, which equals 17. Well done, guys. Next, we've got carbon dioxide, CO2. So you need to look for carbon. You want to look for oxygen. There's 2 oxygens. There's 1 carbon. So just find each of the numbers and pick the right letter and tap on the screen a few times if you think you've got the answer. So we're getting B, we're getting C. We've got 2 answers so far, B and C. No one's got A or D so far. Ooh, we're getting D as well. Okay, so we're getting a mix of answers here. So remember, look for C, look at the bigger numbers. In the periodic table, look for the bigger numbers. So C is 12 and 6, isn't it? Carbon is 12 and 6. Oxygen is 16 and 8. So you pick the bigger numbers here. So it's going to be 12, 16, and another 16. So you do 12 plus 16 plus 16, and the answer is, yep, you guys got it now. It's going to be 44. Well done. Good. Next one, sulfuric acid. All right, they're getting trickier now, guys. So try that out quick and comment what you think the answer is. Tap on the screen a few times and I'll reveal the answer. Thank you, AMT. Okay, so all you have to do, go into the periodic table. Whoops. Look for H, look for S, look for O, and add up all the bigger numbers. So H has 1. S, let's check what S is. S is up again. S is over here. S is 32. So S is 32 and oxygen is 16. Yeah, 16. So you do 32. Let's do the ones first. So 1 plus 1, that's the hydrogens. Then we got S, which is 32. Then we got 4 oxygens here. So you got to do 16 plus 16 plus 16 plus 16. So put that in your calculator. Tell me what you think the answer is and I'll let you know. I'll give you guys a few more seconds to try it. So what we're getting, most people are saying B, 98, 98, 98. Someone's got C. So far, these are the answers we got. B, C, any other answers? So remember, guys, just comment what you think the answer is. Don't be shy. It's a good gauge of me to basically work out how hard the questions are. So if I'm getting a mix of answers, I know people are struggling with it, so I can spend longer explaining it. If loads of people are getting it right, then I know it's an easier question. So we're getting B and C. So people are picking between B and C. All you have to do is 1 plus 1 plus 32 plus 4 16s. And when you add them up, you should get B, 98. Yep, well done, guys. So 98. All right, next one. Which of the following compounds has the highest RFM? Highest RFM. Out of these, what do you guys think? So you can usually tell from the periodic table, the lower down an element is, the higher the atomic masses. So that means the higher the RFM will be. So you can usually tell. So let me know in the comments, guys, what letter you think the answer is. Which one has the highest RFM out of all of these? You can either work them out individually real quick, or you can just look at which ones generally have the elements that are lower down in the periodic table. So what are we getting? We got someone saying C. Any other answers? Someone else said C. All right, quite a few people saying C. Anyone getting anything other than C? So KBR, let's try that out. K in the periodic table is 39. Let me just double check what K is. K is 39. BR is 80. How do you find it again? So let me show you. So BR is here. It's the bigger number. That's 80. K is on this side, 39. So you do 80 plus 39. And then do the same for all of these. We've worked out CO2 already. We worked out CO2 is 44 already. N2, that's nitrogen plus nitrogen. So that's 14 plus 14. So that's going to be 28. Then NaCl. Let's look for Na and let's look for Cl. So Na is up here. Na is 23. and Cl is 35.5. So 23 plus 35.5, and then down here we had 39 plus 80. So out of all of these ones, what do you guys think the answer will be? C. So people are picking C, and C is correct. Yes, well done guys. That is the one with the highest MR. Right, next one. So these are getting trickier. We're getting more complicated MRs. We've got a few more left, and then we'll move on to the next part. We'll try some exam questions. So MR of Na2CO3. So remember, the small numbers tells you how many of the individual atom that you have. So here we've got 2 NAs, Na, Na. Then we've got 1 carbon, and then we've got 3 oxygens. 1, 2, 3 oxygens. So Na is 23, Na is 23, carbon is 12, 16, 16, 16. You want to add all of these up together. So let me know what you think the answers are. So we've got some people saying A. People think the answer's A. See if you agree. Like I said, don't be shy. Just type what you think the answer is, and we can move on to the next question. Okay, so a few people got A. Yep, so you put that all into the calculator, try that out. You get A, 106. Well done, guys. All right, on to the next one. Al2SO43, right? We've got 2 brackets here, so be careful here. So this 3, you use that to multiply everything in this bracket. So what I would do is calculate the SO4 first, then times that by 3, then add the aluminium. So calculate the SO4 first, whatever the SO4 is, times that by 3, then to whatever the answer is, add the Al2. So look at the periodic table, look for what S is, what O is. We already know oxygen is 16. There's 4 oxygens, so we can do 16 times 4. We want to add that to what S is. If you look at what S is in the periodic table, it's 32. So it's 32. So we're doing 32 plus 4 16s, times that by 3, add 2 aluminiums. If you look at the periodic table, aluminium is 27. So you're doing 2 27. So 27 plus 27 plus everything in the brackets. I'll give you guys a bit longer for this one. Let me know what you think. If you're stuck, let me know. I can go through it slower. So when you have the answer, just comment what you think the answer is and tap on the screen a few times. So we got B, we got A. Some people saying A, some people saying B. These are the popular answers right now. So let me know. Why don't you times by 4? You do times by 4. You times this by 4. You times the 16 by 4 here. So you do 32 plus 16 times 4, times that by 3, 27. And then you add the 27 and the 27 again. Okay, so most people have got B here. And B is the correct answer, 342. Why don't you times S by 4? Because this 4 here, because it says SO4, the 4 is only for whatever it's attached to. This is attached to the oxygen. There's no 4 in front of the S. If it was 4 S's, it'll be S4O4, but there isn't. There's only 1 S and there's 4 oxygens. So the number is whatever the number is whatever it's attached to, basically, the element that is attached to directly. Hope that makes sense. On to the next one. We got glucose. So glucose, you would have seen this in photosynthesis, C6H12O6. What's the RFM of C6H12O6? So we've got 6 carbons, each are 12. Add that to hydrogen. Hydrogen is 1, so you're basically doing 12 times 1, which is 12, plus 6 oxygens. Oxygen is 16, so you do 16 times 6. Put that in your calculator. Tell me what you think the answer is. Tap on the screen a few times, and I'll reveal the answer. Yep. So I've got brackets here. You don't need to put the brackets in here. You can just put that all into the calculator. Type that all into the calculator as it is. We've got B is the most popular answer. No other answer really. And yep, that's the right answer. Well done. Okay, let's try then. Let's try an exam question on this then. Let's look at this. So, RFM of a group 2 metal carbonate is 197. We've got the relative atomic masses. So this is what you get from the periodic table. So you technically don't need the periodic table for this question. They've given it to you. Calculate the relative atomic mass of the group 2 metal in the metal carbonate and name the group 2 metal. Right, so what you need to do here is recognize, first of all, it's a carbonate. Does anyone know what the ion for a carbonate is? So it's a metal carbonate, it's a group 2 metal carbonate. The ion for a carbonate, it's going to look like something CO3. So carbonate is CO3. CO2 is carbon dioxide. Carbonate ion is CO3. So this is a group 2 carbonate. So let's look at our periodic table. Let's see where group 2 is. So this whole thing here, let's change the color. This whole thing here is group 2. So that means it's going to be something CO3, group 2 CO3. So it's going to be either beryllium carbonate, it could be magnesium carbonate, and so on. It could be calcium carbonate. It could be any one of these. Our goal is to find out which one it is. So let's try and think about how we can do that. So I'm just going to say it's XCO3 because we're trying to find out what X is. We know the relative formula mass of the whole thing. So the whole thing, the XCO3, has a relative formula mass of 197 in total, right? So what we need to do is we need to first work out what is the MR of just this CO3 part. What's the MR of just CO3? How do we work that out? Well, what we do is we get what carbon is. We know carbon is 12. We know oxygen is 16. So what we can do is 12 plus 16 times 3. If you do that, that's going to give you what CO3 is. So we know that whatever X is, we don't know what element that is, but that plus all of this should equal 197. So if you get your calculator out, work out what this whole bracket is. So you do 12 plus 16 times 3, you should get 60 for this. Yep, someone said 60. That's fine. That's not the final answer then. So we know that one element, X plus 60, gives you an RFM of 197. We want to work out what X is, so we can subtract the 60 from the 197. We can move the 60 to the other side of the equation. So basically minusing 60 from both sides of the equation. So 197 minus 60 gives you, yep, everyone's writing the right answer now, 137. So that's the relative atomic mass of the element, 137. And then we need to find out what metal that is. So what you need to do now you need to look at your periodic table and find out which element has a relative atomic mass of 137. It's going to be one of the ones in group 2. So let's quickly look at a periodic table. We got 9, 24, 40, 88. It's going to be this one, 137. So the answer is barium. So the metal that's present there is barium. All right. So let's just quickly look at what the mark scheme says. To get 3 marks, what do you have to do? So yes, we did this bit correctly. So we get 1 mark there. We worked out the 60. Then you minus the 197 from by the 60 to give you 137. And then identify its barium and you get 3 full marks. So how do you know it's CO3? Because it's a carbonate. A carbonate ion is CO3. It's got a charge of 2 minus. Carbon dioxide is CO2. Carbonate is CO3. Hope that makes sense to everyone. Right, so let's move on. So we've done a few questions on calculating MR. Let's move on. So what is the formula to calculate the number of particles N in a mole of a substance? What's the formula for moles, basically? Pick the right answer. Tap on the screen a few times. Tell me what you think. And we'll write it down in our notes. So A, B, C, or D. The equation for moles. Moles is equal to. So in chemistry, you don't get an equation sheet. Well, you won't for physics either, but yeah, you never did in chemistry. So it's really important that you remember all these formulas. It's not D, no. Moles is equal to. So we got someone saying D, we got someone saying A, we got someone saying B. What do you guys think? Write the answer and tap on the screen a few times. A, Most people are going for A. It is A. Let's write this down in our notes. Moles is equal to mass over mR. Let's write this down here. And when I say mR, I also mean, that basically means RFM. So what we've been doing for the last half an hour, basically. So yeah, these notes I'll be uploading. So on YouTube, I'll upload this whole live and I'll add these notes as well as the questions. So you can try it at home. The equation is moles equals mass over mR. Equation sheet for physics. No, you don't get any equation sheets this year. I'm pretty sure they've stopped giving equation sheets. Okay, moving on. How many moles are there in 36 grams of water? Okay, so we're going to use this equation here. How many moles are there? Moles is equal to mass over mR. Can you guys tell me? Tell me what you think the answer is. Comment the answer, tap on the screen. So you're going to do mass over mR. So look at what the mass is in the question. Look at what the mR is. mR is molar mass. Molar mass is mR or RFM. Both mean the same thing. Giving it to you in here, so you don't even need a equation sheet. You can just use the numbers in the question. In some questions, they just give you the value straight away, so you don't need to use it in the equation sheet. So most people are picking B. Yep, that's correct. B is the answer. So what you do here, mass over mR, we've got the mass here as 36. We've got the mR as 18. So you do 36 over 18. Which is 2. 2 moles is the answer. Well done, guys. Next one. Avogadro's constant is closely related to which of the following? What does Avogadro's constant tell you? Avogadro's constant, the number for Avogadro's constant is 6.02 times 10 to the 23. But what does it actually mean? Why is that number important? What does it mean? Is it the mass of the substance? Is it the volume of a gas? Number of particles in a mole, or the pressure of the gas? Write a comment. Yeah, let me know what you think the answer is. I'm not going live tomorrow. No, next live will be next week. C, most people are typing in C. Yes, that's the definition of a mole. So 1 mole, definition of 1 mole is 1 mole contains, let me get rid of that colon. 1 mole contains the same number of particles as Avogadro's constant, which is 6.02 times 10 to the 23. So 1 mole of any substance, we should probably say, 1 mole of any substance contains the same number of particles as Avogadro's constant, and most of you have typed C as the answer, particles in 1 mole. Yep, good. Next up, okay, so we've got an exam question now. How many atoms are there in 1 gram of argon? Let me know what you think the answer is. 1 gram of argon. Avogadro's constant, I've told you already what Avogadro's constant is. So 1 mole of any substance is equal to 6.02 times 10 to the 23 particles or atoms. So this question is how many atoms are there in 1 gram of argon? So your first thing to do here is to work out how many moles are there in 1 gram of argon. 1 gram of argon. So first thing, find the moles. How do we find out moles? Well, we use that equation that we learned. Moles is equal to mass over mR. You got to find what argon is in the periodic table. Actually, no, they've told you what argon is here. They've told you it's 40. So you need to find the moles. Good. People are writing the answers there. You do moles is equal to mass over mR is 1 gram. That's the mass. So we do 1 divided by the mR, which is 40. 1 over 40. Put that in the calculator. That gives you 0.025, isn't it? So we're halfway there. It's 2 marks. We've got 1 mark. Do you have to remember that equation? You have to remember all equations in chemistry. Yes. Moles equals mass over mR. You need to remember that. We've got the number of moles here. So 0.025 is the number of moles. We want to work out the number of atoms. We know 1 mole is 6.02 times 10 to the 23. So what's the last thing we need to do? So 1 mole has this many particles, this many atoms. How many does this many moles have? All you need to do, so imagine if it asks for 2 moles, for example, if it asks for 2 moles, you'd get this number, you'd get the 6.02 times 10 to the 23 and times it by 2, wouldn't you? So here, what you need to do is you need to get the number of moles. The number of moles is 0.025 and you multiply that by Avogadro's constant, a 6.02 times 10 to the 23. Type that into your calculator and tell me what that gives as an answer. So 0.025 times 6.02 times 10 to the 23. Type that into your calculator. You'll get like a really big answer, and that'll be the answer of the question. You end up with 1.51 times 10 to the 22. All right, so let me explain that question again because I think it's a bit of a confusing question. Let's look at the mark scheme and explain it. So we get 2 marks. So first thing is to get the 1 over 40. How do we get 1 over 40? Because we use the equation moles is equal to mass over mR. So the mass was 1 gram, mR was 40. We do 1 over 40, which gives you 0.025. Why do we times by the Avogadro's constant? Because Avogadro's constant says in 1 mole of any substance is equal to Avogadro's constant, 6.02 times 10 to the 23. So in 1 mole of any substance, there's this many atoms. Imagine if the question asked for what 2 moles had. If it was 2 moles, you'd do 6.02 times 10 to the 23, and then you'd times it by 2, wouldn't you? If it was 3 moles, you'd times it by 3. If it was 4 moles, you'd times it by 4, and so on. This is 0.025 moles. So you just do 6.02 times 10 to the 23 times by 0.025. That's why we times it by the Avogadro's constant. I hope that makes sense. So you multiply all of that and you should get 1.51 times 10 to the 22. I hope that makes sense. Tap on your screen if that made sense and I'll move on. If not, I can explain it one more time. Let me know. Okay, thank you guys. Let's move on to the next one. All right, so this question is percentage by mass. So let's quickly go back to our notes and look at percentage by mass. Okay, so that's this thing here. So let's say we wanted to work out the percentage of an element in a compound. This is the equation, percentage mass. So hopefully this will make more sense once we do an actual question. Percentage mass is equal to the relative atomic mass of the element times by the number of atoms of that element divided by the total MR of the compound. I actually think this equation makes it more confusing than it is. But let me just write that and let me explain using the question. So back to that question. The question's asking what percentage by mass of carbon is in carbon dioxide. So carbon dioxide is CO2 and it's asking what percentage of carbon dioxide is carbon. So some people might think that the answer is like 1 in 3, isn't it? Because there's 3 atoms here. There's a carbon atom, there's an oxygen atom, there's another oxygen atom. So 1 in 3, so that's 33%. But that's not right. What you need to do, so let's look at our equation. You need to get the relative atomic mass, the element. So our element here is carbon. So relative atomic mass of carbon is 12. And you want to times it by the number of carbon atoms in CO2. There's only 1 carbon atom. So you're doing 12 times 1 and you're dividing it by the MR. So that equation, total MR of the whole compound. The MR we've got in the question here as 44. So you do 12 divided by 44. We'll do a few more just in case you guys are confused. Tell me what you think the answer is and then tap on the screen a few times. So we've got people saying A. Any other answers? Another A here. So you're doing 12 over 44 and then times it by 100 to get as a percentage. Don't forget to do that at the end. Why do you times by 1? You times by 1 because this is the equation. Let me go back to the equation. Number of atoms. So you're doing the relative atomic mass times by the number of atoms of carbon. There's only 1 atom of carbon in here. Because it's CO2, there's only 1 atom of carbon, so you times it by 1. If it was C2O2, you would times it by 2. So we'll see an example where you don't times it by 1, you times it by something else. We'll see that in a second. But yeah, when you do that, you get 12 over 44 times by 100. Put that in the calculator and you get 27.3. Answer is A. Well done, guys. So here we've got an actual exam question. This is asking for the percentage by mass of oxygen in ammonium nitrate. Ammonium nitrate, let me write that a bit bigger. NH4NO3. percentage by mass of oxygen. So remember what the equation was. Percentage mass equal to the relative atomic mass, so that's the AR here, times by the number of atoms of that element divided by the total MR of the whole compound. So just try it out. Tell me what you think the answer is. Don't worry if you're wrong. I'm going to go through it. We're going to look at the mark scheme. So do relative atomic mass of oxygen, that's this, times by the number of oxygen atoms. How many oxygen atoms are there in here? Look over there, we've got 3. There's 3 oxygen atoms. So you need to times it by 3 in this one, not 1. In the one before, we had to times it by 1. This one, we're timesing it by 3. We're getting a few answers here. We've got 60, 70, no, 60. So let's try this. So relative atomic mass is 16. Times it by the number of oxygen atoms, which is 3. Divide it by the MR of the whole thing, which they've given you here as 80. So 16 times 3 over 80. And then if you want it as a percentage, you times it by 100. So do all of that and you should get an answer of 60%. Yes, well done, guys. So let's just compare that to what it says in the mark scheme. This is what we're going to do in all our questions. We're going to look at the mark schemes just to see what examiners want, or like alternative ways you can get answers. So 3 times 16, yes, we did that. That's 48. You divide it by 30. Let me know if there's anything you don't understand about this. And then don't forget to times it by 100 because of percentage. So you get a 3rd mark for the final answer. Hope that made sense. We've got another one like this. So let's see if you guys can do this. Percentage by mass of titanium in titanium chloride. This is a bit easier, hopefully. There's only 1 atom of titanium. So remember the equation and see if you can work it out. So everyone try this out. Let me know in the comments what you think the answer is and I'll go through it. So titanium chloride. So percentage is equal to AR or RAM times by number of atoms of titanium divided by the total MR, and then times by 100 if you want it as a percentage. So we're getting a few answers here. We're getting some answers that aren't quite right. Here they haven't given you the MR, so you need to actually work out what the MR is. They haven't given it to you. So remember, for MR you add up all the ARs. You don't just put the number straight. The question before, you just put the number in straight away. This one you don't. We're getting more answers. I still don't think I'm getting the right answer. To keep commenting, guys, let me know. Comment what you think the answers are, just so I know how long to spend explaining this. Don't worry if you're wrong. Okay, so I think I've got a correct answer now. So let me explain. We want the AR of titanium. Here, we've got that here. Remember, it's saying calculate the percentage mass of titanium. So 48 times by the number of titanium atoms here is, it's TiCl4. So there's only 1 titanium atom here, isn't there? There's 4 chlorines, but only 1 titanium. So you do 48 times by 1 divided by the MR of TiCl4. How do we work out the MR? We do 48 plus, and if you look at chlorine, chlorine is 35.5. But there's 4 chlorines, so you do 35.5 times by 4. So keep commenting, guys. Tell me if you're getting different answers now as I go through these questions. So do that bottom bit first. Find out the MR. So 35.5 times by 4, and then add 48. That should give you an answer of 190. So 190 is the MR. So we can put that at the bottom of our fraction here. So 48 over 190, and don't forget to times it by 100 for a percentage. And yep, we're getting the answers now. It is 25.3%. Hopefully that makes sense. Let's quickly look at the mark scheme for that. So you get a mark for getting the 190, so for figuring out what the MR is, and then you get a mark for 25.26 because the question specifically says give it in 3 significant figures. So you would get an extra mark if you just said 25.3 because that's giving it in 3 significant figures. If you didn't give it in 3 significant figures, you wouldn't get this last mark. You'd only get 2. So if it ever specifically tells you to give your answer in a specific number of significant figures, make sure you do that. Hopefully that makes sense. All right, on to the next question. So we got some proper mole calculations here. If you have 0.5 moles of H2O, how many grams of water do you have? This question, let me know what you think the answer is. Comment what you think the answer is. Tap on the screen a few times. and let me know. So for this one, you're going to use the equation moles is equal to mass over mR. Okay, so moles equals mass over mR. We've got our moles here. We've got our mR here. The question's asking how many grams. It's asking for mass. We need to rearrange this equation to get mass as the subject. Mass is equal to moles times mR. Mass is equal to moles times mR. So you need to, yep, I'm seeing some of the answers. Moles is 0.5 times that by 18. And that gives you 9 grams. Yes, well done, guys. Answer's A. On to the next one. Okay, so these are full mole calculations with masses. Let's write some notes on this. So there's 3 basic steps I want you guys to follow when we do these calculations with masses. Crew, K-R-U. Okay, K-R-U. So K is for known, stands for known. That's your first step. Second step is ratio. Third step is unknown. What does known mean? Known is the substance you know information about. So known, the substance you know the mass of. Unknown is the one that you're finding out. So let's go back to that question. Let's identify what's known and what's unknown here. So question says calcium carbonate, CaCO3, decomposes to form calcium oxide. So all of this is like, it's not that important. The balanced equation is this. It's from here, the important bits here. The balanced equation is this. The equation is very important. If you start off with 100 grams of CaCO3, what mass of CaO will be produced? What's known and what's unknown? Known is what you know the information of. We know 100 grams of CaCO3. So let's mark that with a K. Unknown is what we're trying to find out. We're trying to find out the mass of CaO, saying what is the mass of CaO. So we're going to mark that with a U. Okay, so we know our known and our unknown. So let's go back to our steps here. We've got 3 steps. So known means first you calculate the moles of the known using the equation that we know already. Moles is equal to mass over mR. That's always your first step, okay? Moles equals mass over mR. Next step is to use ratio. Let's do that first step first. So known, we've got 100 grams CaCO3. We want to do moles is equal to mass over mR. Mass is 100 grams. We want to divide that by the mR. So the mR is 100. That's given to us here as well. That gives us 1 mole. That's our first stage done. So remember, it's crew, C, R, and U. Those are the 3 steps. 1 mole. Second step is ratio. Ratio, you use the balanced equation. Use the balanced equation to form the ratio. So what you do here is you look at the numbers in front of the known and the unknown. So here, what ratio is it from the known to the unknown? So CaCO3 to CaO, what's the ratio that we have here? There's no numbers in front of either. So that means it's a 1-to-1 ratio. It's a 1-to-1 ratio. So that means if you have 1 moles of CaCO3, it means you have 1 mole of CaO. So 1-to-1 ratio. So the last step here, so if we have 1 mole of, sorry, let me go back. So if we have 1 mole of CaCO3, then that means we also have 1 mole of CaO. Yeah, if it's 2-to-1, you'll see I'm gonna do an example after this where the ratio changes. Here is quite simple when it's 1-to-1. It means you have the mole of the unknown here as 1 as well. So we got a 1-to-1 ratio. So the final step here is to calculate unknown using, so the equation that we had, but we need to rearrange it. We're trying to find out mass is equal to moles times mR. If you follow these steps, guys, you'll be able to do so many more questions. So KRU, crew, known, ratio, unknown. Known, you use moles equals mass over mR. Ratio, use the balanced equation to come up with the ratio. And then unknown, you use that equation again, but you just rearrange it. Mass equals moles times mR. So we're going to use this over and over again for the next few questions. So we've worked out the moles of the known here. We use the ratio to find the moles of the unknown. Now we can work out the mass of the unknown by using the equation. Mass is equal to moles times mR. The moles that we've already got is 1. We've got 1 moles of CaO times by the mR of CaO, which is given to you in the question. It's given as 1 no, not 100. CaO is given as 56. So 56. So you do 1 times 56, and the answer is 56. I'll go through it again. Okay. So final answer is 56. So let me start again. KRU. Always follow these 3 steps. First thing to do, identify what's known. CaCO3 is known because they give us CaCO3 is 100 grams. That's what we know. Unknown is what we're trying to find out. That's CaO. Our first step is to find out the moles of the known. Using the equation, moles is equal to mass over mR. Mass is given as 100 grams here. So we do 100 divided by the mR of our known, which is given as 100 as well. So we do 100 divided by 100, which gives us 1 mole. Then we do the ratio step. Ratio is a 1-to-1 ratio. Why is it a 1-to-1 ratio? Because you look at the numbers in the balanced equation. There's no number in front of CaCO3. There's no number in front of CaO. So they both have a 1 in front. It's a 1-to-1 ratio. If it's a 1-to-1 ratio and your known is a 1 and your unknown is a 1, that means if you had 1 mole here, which we have here, that means for our unknown, we also have 1 mole. So we have 1 mole of our unknown, which is CaO. Now we can move on to our final step, which is to find what our unknown is using the equation, but rearranged. Mass is equal to mole times mR. Our mole we've got here already as 1, times that by the mR of CaO, of our unknown, of what we're trying to work out. That's given here as 56. So we do 1 times 56, which gives 56. Tap on the screen if you get what I am explaining. We're going to do a few more after this, so hopefully you'll really understand. How did you know it was a 1 in front of the CaO? Because there's no number. There would be a number in front. We'll look at a few more examples where there will be a number. Here, if there's no number, it's a 1. That's just the way it is in chemistry. You don't write 1s when you balance equations. You just leave it as it is. Okay, so hopefully that makes sense. Let's try another one. This one. What is the mass of KCl produced from 245 of KClO3? Known and unknown. What's our known here? Our known is that. So KClO3 is our known. So we'll mark that with a K. Our unknown, what mass of KCl is formed? This calculation is hopefully easier. That's our unknown. Remember our 3 steps. Let me give myself a bit more space this time. Let's drop that out. KRU. So our known, we're going to do moles is equal to mass over mR. So our mass is 245 over our mR of KClO3, which is over here, 122.5. Can someone let me know what that is? Put that in the calculator and tell me what that is. 2, yep, thank you. So we've got 2 moles of KClO3. Now ratio, what's the ratio we have here? Known to unknown. Let me know what you think it is. Ratio of known to unknown. So you've got to look at the number in front of the known, in front of the unknown. It is 2 to 2. The equation is the ratio is 2 to 2. That's the same as saying 1 to 1, isn't it? So 1 to 1. So that means if you've got 2 moles of KClO3, you also have 2 moles of your unknown, which is KCl. So now we're ready for our last step to find what the unknown is. Mass is equal to moles times mR. If you've got the answer already, just type in the comments. Let me know. Tap on the screen a few times. So we do 2 times the mR. This time we want the mR of KCl, which is, so people are picking B. That is the right answer. 2 times 74.5 is equal to 149 grams. Yes, the answer is B. Well done. Okay, let's try an exam question on this. 149. Good. All right. Let's try an actual exam question on this. Let's follow the same steps. Gold reacts, says 5 marks. That is a lot of marks for this. Gold reacts with the elements in group 7 of the periodic table. We've got 0.175 grams of gold reacting with chlorine. So first of all, guys, let me know what you think the known is and what the unknown is here. Calculate the mass of chlorine needed to react with 0.175 grams of gold. Give your answer in milligrams. We'll worry about that at the end, but let me know what the known is and what the unknown is. Let me make the question a bit bigger. Hopefully that's a bit better. Is that better? Known, yes. So known is gold, unknown is chlorine. Good. That's our important thing there. Now, remember our steps. Known, ratio, unknown. Let's follow those same steps. We should get to the answer. I think this one, the ratio is going to be a bit tricky, but let's worry about that later. First step, moles equals mass over mR. Let me know if you got the first step already. Type it in the comments and let me know. So you do moles. Yeah, moles is equal to mass over mR. So the mass that we've got is 0.175. Divide that by the mR of gold, which is given here as 197. So you do 0.175 divided by 197. And that gives an answer of quite a small number. So type that in your calculator. You get something like 8.88 times 10 to the minus 4. So that answer, don't delete that from your calculator. Keep that in your calculator and leave it there. So 8.88 times 10 to the minus 4 moles of gold. Okay, so leave that in the calculator. Don't delete it because now we've got the ratio step. Ratio, what's the ratio we've got here? Remember, ratio is known to unknown. 2 to 3, yes, because look, that's got a 2 in front of it. That's got a 3 in front of it. Ratio is 2 to 3. So what do we have to do here? If it's a 2 to 3 ratio, you get that moles that you've got, 8.88 times 10 to the minus 4. If it's a 2 to 3 ratio, you divide by 2 times by 3. Good. So get that number. Remember I said don't delete it off your calculator. So do answer divided by 2 on your calculator. Divided by 2. Then do answer times by 3. Tell me what you get. So divide by 2 and times by 3. We did that because it's a 2 to 3 ratio. Why divide by 2? It's a 2 to 3 ratio. If it was a 1 to 3, you just times by 3. But because it's 2 to 3, you need to first work out what 1 is. So you need to divide it by 2. Then you can times it by 3. Thank you very much, guys. You got 1.33 times 10 to the minus 3. This is the moles of chlorine, moles of CO2. So we've just done the second step. Now we're on to the final step. We want to work out the mass of the unknown. So the unknown is chlorine. So we do mass is equal to moles times mR. The moles that we got is 1.33. So I'll let everyone do this themselves. 1.33 times 10 to the minus 3. This is going to be our last question. So let me know what you get. Times that by the mR of CO2. Let me know what you think the final answer is. So I'll give you guys a bit of time to work that out. And remember, it's mR of CO2, not just of Cl. So Cl on its own is 35.5. The question's asking for Cl2. So remember to times your AR by 2. Let me know what your answers are. So let me recap. We found out the known. We did moles is equal to mass over mR. So we got the 0.175 divided by 197. That was the mR of gold. That gave us 88 times 10 to the minus 4 moles. Then we did a ratio of 2 to 3. We've worked out as 2 to 3 by looking at the equation. When it's 2 to 3, you divide by 2 times it by 3. If it was 3 to 2, you divide by 3 times by 2. But because it's 2 to 3, we divide by 2 times by 3. That gives us 1.33 times 10 to the minus 3. And then, no, that is actually close to the answer. 71 is the MR. So well done for those of you who got 71. That's not the final answer though. So you're just timesing it by 71. So you do 1.33 times 10 to the minus 3 times 71. You should get a really small answer still. Yep, well done. 0.0946, something like this. That's how many grams it is. That's still not the final answer. We got one more step after, but let's make sure we get to this stage. So get the 1.33 times 10 to the minus 3, times it by 71. What is the one extra step we got to do? This is a 5-mark question. We've got 4 out of 5 marks. What's that final mark? 4. Carefully at the question. Convert it. It's asking in milligrams. So milligrams to grams. Think of millimeters to meters. If you want to get from milligrams to grams or grams to milligrams. So this way around, you divide it by 1,000. If you want to get from grams to milligrams, you times by 1,000. So you get your answer here. We want to get it from grams to milligrams. So we do 0.0946 times by 1,000 to get a final answer of, 94, is it 94 or 9.4? 94.6, I think. Let's double check that. Times it by 1,000, not 100. 94.6, yeah, 94.6. So 94.6 milligrams is the final answer, and that's how you get 5 marks from this. Okay, so let's quickly just look at what the mark scheme says, how to get 5 marks. So just like we did, we have our first step here. So this was our crew, K. Then we did a ratio. They've just written it differently. They divided by 2 times by 3, still the same thing. So first we got 8.88 times 10 to the minus whatever it was, I think it was 4. Then we got this, yes, that was fine. Final step was to times it by 71, not 35.5 because it's CO2. And then that gives us 0.0946. And then you times it by 1,000 to change it into milligrams, which gives you a final answer of 94.6. Well done, guys. That was a very heavy lesson. Lots of calculation. You guys did well. So yes, I will upload all of this onto YouTube. I'll give you these questions. There's actually more questions after this as well. I just don't have time to go through them now, but I've got more questions after this with the answers, so you can try them at home. When it comes to the next live, so I'll go live again next week at some point. Why don't you guys comment on my next few videos? Just let me know what topics you want to do, and I'll cover those. I'll try to cover those. I'm not going live tomorrow. Next week at some point, either Friday or Saturday. Just depending on how busy I am, but I'll try. I know you guys got like exams coming up. But yes, so go onto my YouTube, subscribe to my YouTube. I'll upload this. I'll upload yesterday's live as well. Yesterday's one was on cells, and I'll upload all my full videos as well. So yeah, just comment on my videos if you wanna find out. But yeah, thank you very much. Yes, I'm seeing a lot on electrolysis, so I will probably do a live on that at some point. Just look out on my story, because that's where I post what topics we'll be covering in the lives. Glad it helped. Thank you very much, guys. Enjoy the rest of your weekend, and I will see you guys next week.